Okay, we're supposed to determine what the curve has a tangent at the indicated point, and at this point in the course, we haven't found out how to find derivatives of functions. So, what you're really wondering about is, this piecewise function changes at x equals 0. On the left side, we use this function. On the right side of 0, we use this function. So if the curve has a tangent at the point, then it should be able to have a line that only touches at one spot. So negative x, this is the graph. It has a y-intercept of 0, decreases by 1, runs to the right 1, slope negative 1. Then x squared minus x, that does cross at 0. Let's see, so 1 is the other place. So that one looks kind of like this. Okay, so it looks like it might have a tangent, right? If you were to graph that, it kind of looks like a tangent line would only touch one spot. But the only way to know for sure is to use the idea of an instantaneous slope. So to do that, we'll use this notation. We'll evaluate the limit as h approaches 0 of f of a plus h, where a is that point that we're trying to evaluate. So at x equals 0, that means we're plugging 0 in for a. This is just the formula in general. And then, it's minus, because we're calculating the slope between 2 points that are infinitely close. And it's all divided by h. This is y2 minus y1 over x2 minus x1, but x2 and x1 are infinitely close to each other. That's an instantaneous slope. 2 points are infinitely close to one another. Okay, so in our problem, a is 0. That's the point where we're trying to find the instantaneous slope. So we're trying to find the limit as h approaches 0 of f of 0 plus h minus f of 0 divided by h. Okay, but the problem is we don't even know if this limit exists because it could be different on the left side and the right side. So let's do this once from the left. We'll approach 0 from the left, and then we'll see if that matches the slope approaching from the right. If they match, then yes, the tangent line has a slope at this point. If they don't match, then no, that tangent line does not exist here. So you want to do both of these. And it's subtle, that plus and that minus, subtle difference, but it's an important one. Okay. 0 from the left means we use this function. So 0 plus h, that's 0 plus anything is just itself, right? So this is f of h. So for the left side, we're using this function. That means what I've circled is just going to be negative h. And then f of 0 means I'm supposed to plug 0 in here. And it's all divided by h. And this is still the limit notation. My hand's just getting tired, okay? So if you simplify that, that's negative h divided by h, so that's negative 1. We don't even have to do the limit as h approaches 0 from the left because all of our h is canceled out. The slope of this, the left side is negative 1. So I'll write a little note, m equals negative 1. And now we got to check this part. We got to check the slope from the right side of our instantaneous coordinate location. Yeah, x equals 0, either one. Okay, so f of 0 plus h, that's the same thing as f of h. It just means you're supposed to plug in h in here. So it's still the limit as h approaches 0. This is h, so h squared minus h. I just figured out that this is this, okay, because I plugged in h into the right side. And then we're supposed to subtract it by f of 0. If I plug in 0 in here, 0 squared is 0, 0 minus 0 is 0. Okay, and look, you can factor out a 0 from the numerator. So this is the limit as h approaches 0 from the right. So if I factor out an h from the numerator and the denominator, the h's cancel out. Now we don't have a divide by 0 problem. Now you can just plug in 0. 0 minus 1 is negative 1. So we just found out the slope from the right is also negative 1. So does the curve have a tangent at the point? Yes, it's negative 1. Okay, so that's really all you have to do with these problems. Evaluate the slope from the left and from the right.